purpose of this video is for you to be able to solve nuclear equations. This is where something might be missing from them that you'll need to fill in. Now you may need a periodic table to fill in some numbers. And we're very familiar with this notation, nuclear notation, and the top number is the mass number, and the bottom number is the atomic number. Sometimes these numbers won't be filled in, and you'll need to fill them in. That's where the periodic table comes in. You find the element, scandium, on the periodic table. It's right there, and you fill in that its atomic number is 21. Now here are the rules. Basically, put an equal sign where the arrow is, and then you solve the problems, or fill in the spaces, and the top numbers will balance, and the bottom numbers will balance, and you treat them independently. Now, let's use a fruit bowl analogy, just because I think it's a good visual, and it's the same kind of problem. I had a fruit bowl with 6 apples and 7 oranges, and I put some into one fruit bowl, some of the fruit into one fruit bowl. What do I have left over? Well, you have 2 equations to make up and solve. The first one, you can do a minus problem, or you can do an addition problem. You can say 13 minus 6 equals what? Or you can say 13 equals 6 plus what? In either case, the answer is 7. And then you do the same thing on the bottom. 6 minus 3 is equal to 3, or 3 plus 3 gives you 6. And there's the other fruit bowl where I've got 3 apples and 4 oranges. Now let's apply this to a nuclear equation. So here's our problem, all right? And we want to know what this thing is. What is that question mark? Well, the first thing I'm going to do is I'm going to look for any information I can get from my periodic table. And I find molybdenum. It's right here, and that's got an atomic number of 42. The other thing I know about an electron is that it's got a -1 on the bottom. So the 2 things I need to know are what's the number here and what's the number there of this particle. Now I've got a 0 here. Something plus 0 is just the same thing as 99. So 99 plus 0 equals 99. And 43 plus -1 gives me 42. So that's my solution. Okay, next one. Here's the problem, and this one's a little different because it's got an alpha particle in it, and that's really it. It uses a symbol instead of a notation to symbolize what that particle is. Now, americonium is here. Its atomic number is 95. Now, you know alpha particles are this, 4 over 2, always. So 2 plus what gives me 95, 93. 4 plus 239 gives me 234. And here's my solution. Now I wrote it 2 ways. You don't have to write. Notice I wrote it like this and didn't fill in all the numbers, and then I wrote it like this where I filled in all the numbers. Either solution is correct. Here's another problem. This is a fission problem. I've got uranium, and it's a little different because it has a neutron on either side. This is uranium undergoing a fission reaction. We want to know what this nucleus is right there. So I find uranium. It's here. And then I find strontium. It's right here. I fill in their atomic numbers. All right. Now I also know that neutrons don't have an atomic number. There's 0 there on the bottom. So, and 38 plus what gives me 92? 54. What element is that? It's xenon. And what's the mass number? It's 139, because 139 plus this is 234, excuse me, plus 2 times 1 gives me 236. So there's my solution to that one. Now, what's in the middle here? I've got potassium, I've got argon. All right. So first I'm going to find them on the periodic table. Here's potassium, here's argon. that fills in the atomic number there and there. What plus 19 gives me 18? Negative 1. What plus 40 gives me 40? 0. So that is that. Now here I want to figure out what these two things are going to combine to make. Cobalt's in the middle of the periodic table. Here's hydrogen. So I'd fill in their atomic numbers. And 59 plus 1 is 60. 27 plus 1 is 28. And then I look up the element, and 28 is nickel. Now here are some fun facts. This equation was an equation for people have tried to do for cold fusion. This equation is electron capture. You have a lot of potassium in your body, and this is one way that it decays in you. This is a common fission reaction that is used in nuclear bombs. This is an alpha decay that sometimes is used in smoke detectors. And this equation, molybdenum is a byproduct of nuclear reactors, fission reactors. And if they make this element, technetium, which is one of the most common elements used in generating CAT scans or bone scans. It's a radioactive dye that you ingest and then allows them to take an X-ray of the interior of your body.